Alright, we're going to have a little demonstration on a couple of different styles of pumps. I'm going to start with this one. A couple of things, and I have removed some of the bolts just to speed things up when we go to take it apart. When we first look at the pump, alright, if you can see, I have the two sides marked A and B, but you can see where the input shaft is offset slightly to one side. And that kind of gives me an indication when I start to look at this pump style that this is probably going to be an external gear pump with one gear running on this side and another gear of the same size running on the opposite side. Another thing I'd like to point out is that I have already gone ahead and marked this one, and which is a good practice when you're doing this, and you can see that I have two marks that are completely different, but they run through all three parts of the body and housing assembly, so that once I take this apart and it's been sitting on the bench and turned around and upside down and everything else, I know that how it's supposed to go back together, so I don't put something back in the wrong orientation. Looking at this too from the top side, you will see that we have two ports. We have our inlet port and our outlet port. It is a rule that the inlet port is always larger in diameter, and that is to reduce the restriction of oil flowing into the pump. When you look at the sides, you will also see that we have another port in here from each side, and the same thing on the B side, our inlet side, that's port is much bigger than this. And now the reason we have these here is just to accommodate maybe plumbing, where oil would be coming from one side and traveling straight out the other side. Nothing particular about that. When we look at a pump, while you are looking at the shaft, that is how we determine. So if we are moving in one direction such as that would be counterclockwise. So moving like this would be counterclockwise, and if we're looking at the shaft and moving in the direction of a clock, then that would be clockwise. Alright, I've made this little jig, and we're going to set this back in here. We'll take out the last two screws and we'll take it apart and have a look. Having a look at this too, just when you're taking it apart, pay attention, because what you will see on this is that there are two different lengths of screws. So we have 4 short screws, 4 long screws. Just try and remember that, so when you're putting it together, you don't put a short screw into a long hole and it maybe doesn't pull up completely. Alright, I've got all the screws out. It should just come off. There it goes. Alright, so this is in my top plate where we had my inlet and my outlet. Alright, it's sitting like this. So what we want to really pay attention to on this external gear pump is that and we call it an external gear pump because both of these gears have teeth around the outside of them. That determines it, defines it as an external gear. This is connected to my shaft, which is going to be my input, which was, we already said, was on one side of the housing. Get back in the hole. There we go. Alright, so when we look at this, and I'm just going to put a little mark on here so we can keep this. This is my inlet. This is my outlet. Alright, the direction that the gear must turn in order for this to work. The oil is moved around the outside of the gear between the gear tooth and the body of the pump. So as we rotate this in this direction, oil would be moved in here and trapped between the teeth of the two teeth of the gears and the body, and then simply moved around until we get to the outlet side. Now, as this becomes open, we move the fluid into here, but because this is a fixed area, as I'm squeezing the fluid into it, there's no room for it, so that creates my flow. There is no oil travel through the center of the teeth. While those teeth are rotating, there are always 2 points of contact between those teeth. That provides a seal and prevents oil from going from the outlet side to the inlet side. All right. On the surface of this, you'll see that it is very flat. That sits against my gear. This is one of the inspections we would do on it, is to do a flatness check and make sure that there are no wear spots on here or grooves, because what those wear spots will allow is oil to travel from the outlet side to the inlet side. In here as well, you can see that we have a couple of brass bushings. Those provide the support to the ends of the shafts and hold them in the proper place. As we move oil around the outside, we don't want this to move away from the wall, because as these move away from the wall, that will allow is oil to travel back through here, and it lowers the efficiency of the pump. Same with the surface on the top. If we're trying to move oil out the outlet, and there's a lot of space along the top between the top of the gear and this plate, it will also move back to the inlet side. All right, this is an aluminum body, so when you look in here on a pump inspection, you would be looking to see if there's any marks or gouges or wear on these two surfaces on the outside. Depending on the style of pump, you may have a little bit of a clearance between the outside, so you may have a spec where you're looking for with a thickness gauge between the tooth and the body to make sure that it is within spec. When we take this off and take our gears out, we can see that on the bottom we also have a wear plate. The wear plate is copper on one side and stainless steel on the other. There are some small holes drilled in the surface which will allow oil to move through from the gear side in through here and provide a little bit of, and you can see into here where it provides a little bit of an oil flow in and to keep the bushings on the bottom half or the out of the shaft lubricated as well. Now I talked about the direction that this turns, all right, and if sorry, my shaft is missing, all right. So my shaft is sitting in the one position all the time coming through here, but in some cases what I may want to do is have my input switched from either a clockwise rotation to a counterclockwise rotation. Well, that is quite simple or quite easy to do, because as my lines line up here when I put my housing on, drop my gear back in, all right, that's done by just simply taking my housing and turning it around the opposite way. So now my inlet is on this side, and I would simply rotate the gears in the opposite direction so that my fluid flows around and out to here. All right, we'll keep it back together the way it was though, and put a couple of bolts in and move it out of the way. All right, so that is an external gear pump. I'm bringing these two over. This is a pump out of a transmission. This can sometimes be very confusing in the way that it's described. This is an internal gear pump. All right. Now on an internal gear pump, we have our center gear, which is our drive gear, has an external tooth on it. But that external tooth meshes with a gear that has an internal tooth. That is why we call this an internal gear pump. Now, one of the big differences between this pump and the other pump is that my center gear is the input for this one. It's always going to be the center gear. On this one, we have two flats on the center, which would made onto the torque converter shaft. So when my engine is turning, this pump is driving. When it turns, and what we saw with the external gear pump was that when one gear turned in one direction, the other gear turned in the opposite direction. On an internal gear pump, the external gear, this is always confusing, the external gear is in the middle, and the external gear rotates in the same direction as the internal gear on the outside. These line up with, and if you look at it here, what we have as these two gears are rotating, we have a space which is getting larger continuously on this side of the pump. The oil becomes trapped between the teeth of the gear and the crescent here, and then when we move to the outlet side, as we rotate the gears, this space becomes smaller, forcing the oil to move, and that creates our flow. The void opening up creates a low pressure and draws the fluid in, and as we move this, we're forcing the oil outward. So, and again, this is a pump, and a pump creates flow. Remember that it has an external gear on the inside and an internal gear on the outside, and that they move in the same direction. All right, now these are both another type of internal gear, but they are more specifically referred to as a gerotor or gear rotor or G-rotor. I do not care which one you use, but they're very similar in that we have an external gear in the middle and an internal gear on the outside. The thing that makes these a little different is that if we are to count the teeth around the external gear, it will always be one tooth more on the internal gear. And it does not, that rule does not change. It does not depend whether it has that many or this many. I'll just use this one because it's nice and simple. So on my external gear here, don't look at the splines on the inside, we have 1, 2, 3, 4, 5, 6 teeth. On my internal gear on the outside, I have 1, 2, 3, 4, 5, 6, 7. One additional tooth. Now, the way that this works is very similar to the internal gear, and I always use this masking tape because it works nice, right? Is that as we rotate the shaft, trying to get this in the camera, you can see that the internal gear on the outside is rotated by the external gear on the inside. All right. We'll have these in class and in lab, and hopefully you can have a look at them there and see it a little better as well. That's pretty much it. So gerotor is a type of internal gear. Sometimes this internal gear is also referred to as a crescent gear because of this crescent that's present in the middle of it. All right.